In calculus, one of the simplest law is this: when when a function y is equal to ax raised to power n, and we are asked to differentiate this. This is the y dx. The y dx is the derivative of y. So the y dx dy dx will be equal to, we'll bring this n, which is the power of x, out here. Okay, so we say n, then we'll subtract 1 from the power. So that means we have differentiated the function. We use the power to multiply a new function, which is n minus 1. Okay, so the power multiply the function when the power is subtracted by 1. Subtract, use the power, bring the power down here, then subtract 1 from the power of the function. Those are the two things that we do. This n, this is n, you write n here, then times ax raised to power, instead of writing n, you write n minus 1. Bring down n here to multiply the function, but the new function, we have a new power, which is 1 subtracted from the original power. Example, differentiate y equals 3x power 4, y equals x power 5, and y equals x. Now the first one, we said y is equal to 3x raised to power 4. Now follow our principle, the power is 4, so the y dx will be equal to 4 into the same function, which is 3x raised to power 4, but we have to subtract 1 from it. That's 4 minus 1. So we have 4 into the open bracket, 3x raised to power 4 minus 1. We always subtract 1 from the power, from the original power, from the old power. So the power was 4, but now it will become 3. Now to open the bracket, we say 4 times 3, that gave us 12. So if y is 3x raised to power 4, the y dx will be 12x raised to power of 3. That is how we do that differentiation. Another question is y equals x raised to power 5. Now the y dx will be equal to, bring the 5 out, is the 5 times the original function, which was x raised to power 5, then subtract 1 from the power. So that is 5x raised to power 4. So our y is x raised to power 5, then the y dx is 5x raised to power 4. Now the last one is y equals x, then our dy dx. Note that the coefficient of x here is 1 and the power is 1. So bring down the coefficient, bring down the power, which is 1, then x raised to power 1, then subtract 1 from the power again. The old power was 1, so we subtract 1 from it. So we have 1 times x raised to power 0, because when you take 1 from 1, you have 0. So the power now is what? 0. So when we differentiate that, x raised to power 0 from law of indices is 1. Okay, so when we differentiate y equals x, we get 1. It's a very simple rule that we can investigate. We say y equals 2x, the derivative, the dy dx will be 2, and then if we differentiate, if we are given y equals 5x, the y dx will also be what? 5. For this, our dy dx will be 2. For this, our dy dx will be 5. Now when we have something like y equals, if y is equal to let's say 0.5x, the dy dx, what will it be? It should be 0.5. So that is how to do this differentiation. This is a very simple example, and these are very simple examples that we have here. In the subsequent video, we'll try and differentiate stuff like y equals x raised to power, let's say 2 over 3 now. So when we have this as our function, and y is equal to x raised to 2 over 3, some things of stuff like radicals, those are the ones we are going to look at in the next video. But I hope you understand this one, especially the rule. If you understand the rule, you can all easily apply it to answer questions. These are the type of calculus problem that we expect at the very basic level. And we have not used first principle to answer this question. We have actually used the second principle. I thank you for watching my video. I hope you enjoyed it. I would like you to leave your comments and also subscribe to my channel so that you can enjoy every update that I bring your way. I wish you success.